more with function operations, and then in the later part of the lesson, we'll learn a new operation. So we did learn this in 7-6. We will jump back to 7-4 tomorrow. I just wanted a full day and not a day the first day back, because it's one of the harder lessons. So today we're doing 7-5. We're going to start out with function operations, which we just learned in 7-6. So we learned these few operations. Addition, if we have f plus g and they're both functions of x, that's simply f of x plus g of x. So you can just split it apart. Just new notation, right? And then if we have subtraction, f minus g, they're both functions of x, so that's f of x minus g of x. With subtraction, this is a big, be careful one with huge red flags. Be careful, because if you have a negative and you're subtracting g of x, don't you have to subtract all of g of x? So you got to distribute our negative through. All right, multiplication, f times g, they're both functions of x, so that's f of x times g of x. When multiplying, we might have to double distribute or distribute to multiple terms. So we got to be really careful. And then we would combine like terms. Then division, at this level, we don't have to do any really simplification with division. We simply have f divided by g of x, which is f of x divided by g of x. Now the good news is, you will see this in secondary 3 again, and you guys will have mastered it in secondary 2. So secondary 3, when it gets a little bit harder, you'll get harder functions. But it's not going to be hard for you because you've got it mastered with a little bit more basic ones this year. Okay, so let's just practice a few, then I'll just let you work. Now, make sure, first example here. So we're given these three functions, f of x, g of x, and h of x. Does everybody see our three functions above? Okay, so now we're asked to find f plus g of x. So we look at this, f plus g of x. We know that simply means to find f of x plus g of x. All right, what is f of x? X squared plus x minus 2, and I'm going to put parentheses plus g of x, which is 5 minus 3x. Now I'm going to ask you, do we need to distribute or do anything here? Nope. No, distributing is a multiplication property. We're simply combining my terms. So we don't even need the parentheses. So we start with our highest degree, work our way down. X squared, no other x squareds. Cross them out as you go so you don't miss anything. X plus negative 3x. Negative 2x. And then negative 2 plus 5 plus 3. So that's f plus g of x. Questions on that? So in the next part it says find f plus g of 2. Well, we just found f plus g of x. So f plus g of 2 instead of a x. Isn't there a 2? Yep. So don't we just plug in 2 wherever there's an x? Yep. Into our function. Okay. So we're going to have 2 squared minus 2 times 2 plus 3. Now notice how anytime I substitute something in, I put parentheses around it. If you're going to type it into your calculator, you have to use parentheses. Okay? And if not, we're going to calculate this correctly. This is not that hard though. 2 squared is 4, right? Minus 2 times 2 is 4 plus 3. What's 4 minus 4? 0, right? So 0 plus 3, which is? 3. So f plus g of 2 is 3. Okay? So a couple more, then I'll let you do the front page. Stay with me. F of x, g of x, h of x. The same three functions, guys. We're now finding h minus g of x. So isn't that just h of x minus g of x? Okay, this is where most people mess up. But guys, at this level, I do expect you to not mess up on subtraction. Something that we're at this level, we should not be messing up on something of this level, okay? H of x, what is it?
4x plus 1.
4x plus 1. Then we're subtracting g of x.
5 minus 3x.
Okay, so carefully looking at this. This is subtraction. Now, we have this negative in front of this whole thing, right? So we need to distribute that negative through to both terms. So really, we have a negative 1 here. What's negative 1 times 5?
Negative 5.
What's negative 1 times negative 3x? Positive 3x. Okay, so now from there, we can just ignore this because we just distributed our negative through and just combine like terms. 4x plus 3x. 7x. 1 minus 5.
Is that squared?
Not squared. Good question. When we add these, do we add the exponents? No, only when we're multiplying, right? So an apple plus an apple is just 2 apples, not 2 apple squares. Good question. So now we have 1 minus 5.
4.
Minus 4. So we have 7x minus 4. That is h minus g of x. Now we're doing h minus g of negative 1. So instead of an x, there's a negative 1. So we have 7 times negative 1. Instead of an x, there's a negative 1 minus 4. Now you have to use parentheses, but that's negative 7 minus 4, which is negative 11. Is everybody comfortable with that? Last two examples, and I'll let you work. You guys, I really do expect you to not get subtraction wrong today. Okay? All right. F times h of x. So we know this simply means f of x times h of x. F of x is x squared plus x minus 2. With multiplication, we always use parentheses. Times h of x, which is 4x plus 1. Now that one looks a little tricky, but I know we can do it. So don't we have to multiply all this stuff to all this stuff? So we're going to have quite a few distributions here. So stay with me and very carefully. X squared times 4x. 4x squared. No, not quite. That's 4x cubed. Good. All right, x squared times positive 1. Positive x squared. Is everybody comfortable with that? Well, I distributed x squared through to both terms. Now I'm going to distribute positive x through. Positive x times 4x. 4x squared. Positive x times 1.
Okay.
Plus 1x or plus x, same thing. I'm going to change colors again. So negative 2 times 4x. And then negative 2 times positive 1. Now we'll combine like terms, starting with my highest degree. Isn't that 4x cubed? No other x cubes. 1x squared plus 4x squared. 5x squared. 1x minus 8x. Minus 7x, right? And then minus 2. There's f times h of x.
What is this for again? Is it just completely different from?
No, we're just reviewing what we already learned. Wait, what do you mean?
Okay.
Okay. So now it says find x times h of 0. Are we just plugging in 0 or there's an x? So we have 4 times 0 cubed plus 5 times 0 squared minus 7 times 0, and then we had a minus 2. So isn't this going to be 0 plus 0 plus 0 minus 2? So that's just negative 2. However, if you did type in that full thing to your calculator, you'd get the same answer. Okay? All right, next one. Last one, then I'll let you do the front page. Okay, here we go. Given these three functions, find g divided by h of 2. So this time we're just asked to find g divided by h of 2. So let's just find g divided by h of x and then plug in 2. So that's g of x divided by h of x. What is g of x?
3x.
And then h of x is... And then this is where people get lazy. Okay, so we're plugging in instead of an x of 2. So we have 5 minus 3 times 2 divided by 4 times 2 plus 1. And then I have people just type it in, hit enter. You'll get it wrong. You have to be good at knowing that your calculator has no idea order of operations. So it doesn't multiplication and division. Okay, let me help this make sense to you guys. Is that multiplication and division hand in hand?
Yeah.
Okay, so if you just type that into your calculator, do you see how at this point you have 5 minus 3 times 2 divided by 4 times 2? Your calculator has no idea if it should divide, so it'll just do it in order of what you type it in. Because division and multiplication go hand in hand. So your calculator will go 5 minus 3 times 2 divided by 4 times 2. It'll hit enter, then plus 1. So guys, your calculator, if you just type it in, has no idea what goes where. So you need to just type it in on top. What do you get on top?
1. Negative 1.
Negative 1. What do you get on bottom? Negative 1 over 9. And now you can type it into your calculator now that you have a fraction, but that is the simplified fraction, right?
Yep.
So we're done. Do you guys all understand what I'm saying when you can't just type it into your calculator at this point? Okay. All right, so do 1 through 7 on the front. Get them right. That's what's important today. Let's get it. Okay, so there's one more operation we have yet to learn. This is called function composition. Once again, function composition. So you can take a function and compose it from another function. So we're going to be given 2 or more different functions. We're going to take those 2 functions and compose a new function from this function. So this is the notation, f(g) of x. So that little O is a little circle, an open circle. So not to be confused with multiplication. Does everybody see the open circle?
Yeah.
That reads f composed of g of x. So we're composing, so f composed of g of x. So we have a function f, a g, and they're both functions of x. And we're composing g back into x. So there's 2 different ways of writing this. F of g of x, which is equal to f of g of x. So f of g of x. So we can rewrite it either way. Anytime I see it like this, I rewrite it like this side, because then it's pretty easy from there to see what we're doing. Now, I'm going to give you a little trick. This isn't a mathematical trick. It's just a way that helps me remember how I take something from this form and squish it together to have it in this form. Because once we have it in this form, it'll make more sense on how to do it. So FOG of x, if I want to rewrite it like this is a little trick that I kind of came up with myself. If you take x and squish it back in with g, so we're squishing this way. If we take x, squish it back in with g, isn't that g of x?
Yep.
Now if you squish it back in one more time, so if we take it and squish it back in one more time, won't that be squished back into f? So that's how we get f of g of x. That's not mathematically how, but that's just a little trick. Does that make sense, everybody? Yes.
Wow.
Okay? So once again, that's not mathematically anything. It's just picture yourself grabbing x, squishing it back in with g. That's g of x. Squish it back in one more time. That's f of g of x. Okay, so now this is how this function composition works. Okay, so I want you to look really quick with me. This is not function composition. I'm trying to help you see function composition in the future. This is not function composition. If I said f of 2, wouldn't we just substitute in 2 in for x wherever there's an x in f?
Yes.
Wouldn't we?
Yes.
Wouldn't we just put a 2 in for x?
Yes.
We'd substitute it in. So we wouldn't we'd put a 2 in there, so we would have literally, instead of an x, wouldn't we have a 2 minus 1?
Yep.
Which is just, 1, right?
Right.
Okay, so with that being said, looking at f of g of x, do you see how in the parentheses, just like the 2, there's now a g of x? Does everybody see how instead of a 2, I have a g of x?
Yeah.
It's going to work the same way. We're going to plug in g of x wherever there's an x and for x. So, didn't we just take the 2, plug it in for x?
Right.
So when we just take g of x, plug it in for x?
Right.
Yeah. So we'll have g of x in parentheses minus 1. Well, what is g of x?
2.
2 in this example. So we would do 2 minus 1, which is 1. So this is an example of function composition. So we'll do another one. Yes.
Something like that one math operation where you have something set equal to another thing and you plug it into wherever x is.
Kinda. Yeah. Yes. No, it wasn't. It's just I made my parentheses really dramatic on this because it's just g of x like this. So good question. That's not an exponent. It kind of looks like it, but it's just I'm saying g of x. Okay. So once again, don't get caught up. Once again, here's what happens. Most people multiply when they're supposed to be doing function composition. We didn't multiply anything, did we?
No.
We plugged it in instead of an x, that g of x. So let's do another one. We're going to start out with some easy ones. So we're given these two functions. F of x is this, g of x is this. We want to find f of g of x. So we're plugging in this, right? So I'm going to locate g of x. Isn't this g of x? Are we substituting that in for x wherever there's an x in f, right? So what we have in this easier example is that negative 10. Anytime we make a substitution, we put parentheses. So instead of x, I'm putting in negative 10 minus 5. Does everybody see how this is literally equal to this? It's just I made a substitution.
Yep.
Okay, so what is negative 10 minus 5? So that was f of g of x, negative 15. We're going to do some easy ones for a second. Okay, given these two functions, we're finding f of g of x. So once again, you got to look in your parentheses. We're substituting in g of x in for x into f, right? Wherever there's an x. So I'm substituting in g of x, which is 5, and for x, wherever there's an x. We're substituting it in. When we make a substitution, it replaces it, right? Okay, so we're going to have 5 squared, because we're substituting that in, plus 5. Questions on where the substitution was made? So that's 25 plus 5 in this problem, which is 30. Okay, next one. A little bit harder. So looking at this, given these two functions, we're finding g of f of x. So this time, aren't we substituting in f of x in for g?
Yep.
So I'm going to locate f of x. We're substituting in that into g wherever there's an x. Now don't multiply it. That's not how function composition works. We are literally replacing x, substituting in for x, function f. So instead of an x, won't there be an x squared plus 1? Minus 1.
So
Okay.
it's not always going to be an exact number. So
No, it's not. So this was our first harder example. So here we go. Instead of an x, I'm substituting in f of x for x, right? So instead of an x, I have x squared minus 1. Does everybody see how that was for x?
-2.
And then we still have our minus 2. Do you see how they just replaced? Okay, then from there, okay, then from there we'll combine like terms and simplify it. So looking at this, no x squared, right?
Nope.
Besides that, and then what's -1 minus 2? And it was subtraction, right? So minus 3. Okay, a little bit harder example. Next one's a little bit harder. So given the two functions, f of x, g of x, we're finding f of g of x. So I say to myself, okay, I'm substituting in g of x into f wherever there's an x. So I locate g of x. Isn't this g of x?
Yep.
We're substituting it in for x into the other function wherever there's an x. Does everybody see where I'm making the substitution? So there's no longer an x there. It's an x minus 2 there. So in parentheses, x minus 2. That's that. Squared minus 1. Does everybody see where I made the substitution on that? Okay, so then let's actually multiply this out. Now, can we just square this, square this?
Nope.
No, that's the first most forbidden rule that you ever learned in my class. So we know that this is the same thing as x minus 2 times x minus 2, right?
Right.
And we still have our minus 1. So let's distribute. So we'll have x squared minus 2x minus 2x plus 4, and then don't forget about that minus 1, right? Combine like terms. X squared minus 4x, and those
+3.
plus 3. Very good. And that is f composed of g.
Whoa.
Okay. Last ones, and I'll let you work for a second. Stay with me. These are the hardest ones for people, and it's because then I was so frustrated because in first hour, the people that were trying to not do it the way I showed couldn't get it right. So everybody, I give you suggestions for a reason. So we're given f of x. These are two different problems. We're finding f of x. So we're plugging function f back into f, right? Everybody? Isn't that f back into f? Well, this is a lot harder for me if I'm trying to just picture it. So I will write that out twice. So I have two f of x's technically, right? So we have x plus 1, and we have f of x is equal to x plus 1. Do you see how I have two of them now?
Right.
Now it's a little bit easier for me to say, okay, so I'm plugging f of x back into f of x wherever there's an x, right? Do you see how I made the replacement? If I have them both written out, and I still to this day draw myself a little I say, okay, so I'm taking this and substituting it in for x wherever there's an x. Okay, then it's easy to see. So we're going to have x plus 1 plus 1. Do you guys see what I'm saying?
Yes.
So then combine like terms. That's x plus 2. That's f of x. Okay. Next one. So we have g of x. Well, it's kind of hard if I only have one g of x because I can't do the little circle thing. I like to do it just for my own self. So we have two g of x's technically. We're plugging g of x back into g of x. So we're taking g of x, we're substituting it back into g of x wherever there's an x, right?
Right.
I always draw my arrows like this. It doesn't hurt. So don't multiply them. That's not what function composition is. Are we substituting it in? There's no longer that x there, right?
Right.
So we have -5 times -5x. We substituted in function g of x in for x. So now, yeah, you would multiply. Wouldn't that be 25x?
Yep.
That's g composed of g of x. Okay. So you're going to go onto the back page, do 10 through 12. On the back, check your answers with me. Then do not move on. Just do 10 through 12 on the back. Check with me, we'll move on. Yeah, be really careful not to mix up multiplication and function composition. It's easy to mistake it. Okay, so now we're going to do these two problems off the worksheet. I'm going to show you two ways to do it. There's an easy way and a not hard way. I mean, it's harder, so you can choose which way you're going to do it. Okay, so we have f of x, g of x, h of x. These are your problems off your worksheet. We're asked to find f of g of -3. Isn't this function composition? Okay, so we're substituting in g of x in for x, into f, right? Right, everybody? So I'm going to do it two different ways. The first way is the one way you can do it. So really, let's just find f of g of x first. Isn't that really what we're doing? And then can't we plug in a -3 in the end?
Oh, yeah, that's next.
Okay, let's find f of g of x. So that would be taking g of x, substituting it in for f, in for x, wherever there's an x, right?
Yep.
So that's 2 times 3x. Anytime we make a substitution, it replaces it, and then minus 1. So then from there, we would have 6x minus 1, right? But that's f of g of x. We want f of g of negative 3. So 6 times negative 3 minus 1.
Negative 19.
Negative 18 minus 1 is negative 19. Okay, now here's another way to do it. You'll want to watch this because this is much easier. You can do it that way, but here's the easier way. So what you can do is say, okay, with function composition, this is the only time we can really do this. Let's find g of negative 3. So isn't that plugging in a negative 3 for x?
Yep.
So that would be
Negative 9.
negative 9, right? So f of, we did g of negative 3. What's 3 times negative 3?
9.
Negative 9.
Negative 9. So isn't that just f of negative 9?
Right.
Do you see how I just calculated the inside? Which f of negative 9, we can find that 2 times negative 9 minus 1.
Oh, man.
Negative 18 minus 1, negative 19.
Oh, my.
So pretty easy, right?
Yeah.
Okay.
Yeah.
So I'm going to just do this one the easy way.
It's like dummy.
F of h of 7. So we have f of h of 7. So I'm going to first calculate h of 7. So that's going to be
15.
7 squared plus 1. So 49 plus 1.
50.
So 50. So that's f of, that was just this piece. So now we're finding f of 50. Because I just simplified h of 7. It was 50. Does everybody understand that? So f of 50, plugging in 50, we have 2 times 50 minus 1. 100 minus 1 is 99. So you can work yourself, guys, you always work from the inside out. Inside out. Does that make sense? Okay. Awesome. Finish the worksheet. The rest of the time is yours.
You, 30.